Welcome back to part 3 on my 70 loan CMBS model. In this video, I will tie the remaining elements of the model together, those being the balances, liabilities, outputs, and control panel tabs. I will briefly touch on the principal waterfall before describing how all of the worksheets work together to value each tranche. The principal waterfall is one of the more straightforward sheets in the workbook. I touched on how the minimum ASB balance worked in part 1 of this series, so suffice it to say that the remaining tranches pay down sequentially in order besides tranche ASB. For example, tranche AS takes the minimum of the remaining cash flow after paying down the more senior tranches and tranche AS's beginning balance. This works so that principal is not overpaid. At most, it will pay down the remaining of AS's beginning balance, and then principal will be distributed to the next tranche. As principal gets distributed into the tranches period by period, the question remains how to discern when principal should move from one tranche to the next and how the beginning balances are calculated. Here's how it happens. As principal is distributed, it is then pulled into the respective balance. The balance gets reduced by that amount of principal, with interest being calculated by multiplying the beginning balance by the correct interest rate. You can see that happen here in the interest tab. Then the output sheet pulls the entire model together. The principal balance is pulled up top with the percentage of aggregate balance calculated. For the payoff date, I had to be a little creative. What this formula is doing is finding the period when the balance of the principal for the tranche equals 0. You might wonder why not just look up the period when payments equal 0 in the tranche here in the outputs page. Well, that would work for the senior tranches, but for the junior tranches, when cash flow is distributed unevenly, or it might be 0 for a certain period, the formula wouldn't work. The IRR formula uses a similar strategy here. Because the IRR formula is dependent on the start and end period, I can't use 120 periods for each tranche, right? Because the senior tranches may get paid off sooner and will likely get paid off sooner than that. So the IRR formula extends until the principal balance in the respective tranche equals 0. Now the question is, does the model work? Initially, we have two tests, one for VBA amortization and another for cash in and cash out. In terms of VBA amortization, the test is positive when the sum of all the loans in period 0 on the loan tape equals the sum of all the loans in the VBA amortization. As a quick check, you can see here that that is true. This is a simple test and quite effective. However, if you want to have a more robust version of the test, you could amortize a loan independently in the worksheet and check that the loan array equals the loan you amortize in Excel. So the array may run 73 loans. For loan 3, you would model that out in the workbook and then check that each period of the array's amortization equals the amortization that you calculated in the workbook. Then there is the cash in equals cash out test. I touched on this test in the RMBS model series, but effectively all the money that comes in through the loans paying interest, principal, or balloon payments less fees must be accounted for. Now, if I change certain inputs, we expect a certain result in our outputs. Let's say that I bump up prepayments. Now, price will likely decrease across the board. In addition, though, we can see that for the XA tranche, Excel can no longer calculate an IRR. For the senior tranches which pay principal, prepayments affect the tranches by reducing the amount of interest paid. However, principal is paid back at a faster rate and tranches are paid back in full. Let's think about tranche XA. Because excess interest from only the senior tranches is paid to XA, when the senior tranches pay down, XA's yields are radically reduced as it receives no early principal, only a lack of interest. Therefore, it makes sense that the IRR calculation cannot calculate in this case. So that's the CMBS model. I hope you enjoyed the series. Thank you.